I have a second channel, Cube Comp MTDX.
Hey everybody, in this video I'm going to be putting together this Thunkit Electronics MAKIT-THT. This is a 100% DIY through-hole version of an Arduino Uno. It uses all through-hole components and also has a built-in USB to UART interface IC. It is an Arduino Uno compatible board that uses only through-hole components. Whereas, of course, the regular Arduinos, they have, I think, mostly surface mount. So, what's neat is, so this person, they pretty much reverse engineered the Arduino. Used, let me just read here. They used the ATmega 328P, which I think is the same exact microcontroller that is used on the Arduino Uno, except they use a different package. Of course, they use the a dual inline package because it's through hole. What's really cool about this is the guy has this design is actually open source. So if you're into electronics and you know how to write like in KiCad, know how to custom design circuit boards, you can redesign this to your own liking, provided you credit the author. The community college I work at, we actually have our own version of this. It's mostly designed off the MAKIT-THT, but it actually uses a standalone USB to UART USB interface. It's a standalone circuit board that we actually solder on to the primary circuit board. But anyways, in this video I'm going to just be talking about putting together this one. So what's cool is, like I say, the author of this project has everything listed. This is a bill of materials, supplier and reference. He mentions the suppliers and everything. And if you go on his website, which I'll put a link in the description if you're below, if you're watching this on a computer or mobile device. If you go to his website, it'll tell you everything about this. It includes a schematic of the circuit. It also, like I say, includes all the information you need. So, yes, the MAKIT-THT uses ATmega 328P, the same as the Arduino Uno, and the MCP2221A USB to UART IC for the USB interface between the board and your PC. So, enough reading. Let's go ahead and get started on this thing. I know it's like almost 3.5 minutes into the video now. So, I'm going to actually follow the instructions here on the website. Though on the website there is actually a link to download a printable PDF. Okay, everybody. So here you're looking at all the various components that come in the kit. You see you get an assortment of various capacitors. You get some 1 microfarad ceramic capacitors and some 22 picofarad ceramic capacitors. There's the LED, various headers, power jack, the diode. It's your 5-volt linear regulator, 7805. You have your 3.3 volt regulator. Here's you a little bit of a close-up of it when we get focus. Camera's not going to cooperate, is it? Anyways, we have this little tactile push button switch. We have a USB port. We have the ATmega 328P and the MCP 222 1A, and you have two dip sockets there, one for the USB UART and one for the microcontroller. Sorry if I can't get this right with the camera, of course facing me. So there you have it, guys. So you're going to need a soldering iron, you're going to need a solder sucker, you're going to need the soldering wick or braid, you're going to need a set of cutters, recommend a vise or any means of holding the PCB, and of course you're going to need some solder. I have both leaded and lead-free solder here. Now, from my personal experience, lead solder, it flows so much better, although you may want to use lead-free. So let's go ahead and get everything ready. Let's go and get started. Okay, so here's the PCB, and let me turn it around the right direction so that way it's facing the right direction for you. So the side you're looking at right now, this is the top facing side. So this is the side that the components will be on, and this is the bottom side right here. I will say they did choose a decent quality PCB. Now, from my experience, now I'm not the one who actually ordered the PCBs for our kit, but at the college I work at, but they typically use a certain supplier. You can choose a supplier to a company to actually manufacture your circuit board. You send them the schematic, and then they basically manufacture your board for you for a fee. And I say this is a decent circuit board. I think it would hold up pretty well. Now, one thing I do suggest is before you actually start soldering on this, if you have any old electronics laying around you don't care about, I would personally suggest practicing with soldering before taking on this project, because the better you are at soldering, the better this will go, and the more chances that it'll work. So, again, this side is the top side. So what I'm going to do is I'm going to go ahead and install this into the vise here, and we will have to move it around on occasion. And I must say the directions are pretty well laid out. And the method that they choose to put this, the order that they choose to install the components, I'd say is very good. Because you generally want to start with small items first, and then work your way up to taller items. So the first thing we're going to do is install the resistors. So we have 4 resistors to install. We have 2 1K ohm resistors, which have the brown, black, red, gold color band. We'll go ahead and take the paper off the edges of these, and we'll insert these into the respective locations. So R1 and R2, just double check the parts list here. Yep, so R1 and R2 are the 1Ks. So with the resistors, you just bend the leads like that. And you can slide the resistor into the board. And my suggestion is to try to get as good of a bend as possible, so that way the resistor goes in straight. As you've seen, it kind of went at a little bit of an angle. And you generally want the resistor to sit pretty flush with the board. And when you get it down far enough, you just bend one lead that way and one lead that way, and it will hold the resistor in the it'll hold the resistor in place. So that's R2. So now we'll go and install R1, which again is a 1K ohm. Next, we'll install R4, which is a 330 ohm resistor. And it follows the color bands orange, orange, brown, gold. And again, just the same as we did R1 and R2. And sometimes you can use a pair of pliers, needle nose pliers, to pull the lead in to get it straight. Just don't pull too hard, otherwise you could break the lead off the resistor or other component. I'm going to install R3, which is a 10K ohm resistor. R3 goes right there, and the 10K ohm is a brown, black, orange, gold band. So again, brown, black, orange, gold. And just like before, we'll just bend these leads like that. And we'll install R3. Now I should mention that the resistors are not polarized. They can be installed either way. It does not matter which way you put them in. Okay, so now that we have the 4 resistors in place, we can go and solder them in. So I'm just going to go ahead and pull the PCB out, flip it over. And generally, I like to solder the components first, and then I'll trim back the leads. So, here's our soldering iron. I'm going to clean it off here. Now we have a good shiny tip. Let's go ahead and apply some solder. Just be careful not to overdo it. You only need just a little bit. And be careful to not leave the soldering iron too long on the lead, because it can overheat it. It can cause damage to the PCB, or it can cause damage to the component. Now resistors, they're generally pretty hardy. They're not super fragile, but other components are fragile, so keep that in mind. Okay, so now what we'll do is we'll trim the excess off of the leads, just like this. And these cutters don't quite go as deep as I generally like, so having to work with them. Okay, now what you need to do is just verify your lead, your solder connections. Make sure you don't have any missing solder. What I mean to say is make sure that there's not too little solder on the connection. The trace, the contact point should be covered in solder. And these resistors, they're soldered in, so now we're going to move on to the next part, which will be the capacitors. You know, with the capacitors, I'm going to do as they do. I'll first insert the 22 picofarad capacitors, followed by the 0.1 microfarad capacitors, and then I'll turn the board over and complete all of the solder connections. Now, of course, need to take note of where all the capacitor locations are. We have C5 right there, C1 and C4 right there, and C8 right there. C3 right there, C2, C7, C6, So I'm going to actually insert the board like this. Now this vise has rubber on it, so of course it's pretty easy on stuff like this, but you still gotta be careful. And these particular capacitors, these ceramic capacitors, are not polarized. However, some capacitors are, particularly tantalum and electrolytic. Those are polarized, so keep that in mind. Now with the capacitors, what we can do is we can just trim these off. So these two are the 22 picofarad capacitors, and you can see in this kit they're marked. I'm not sure if I want to say that the supplier, they marked them, or at least the supplier of the kit marked them. But if you end up getting this kit and they're not marked, the 22 picofarad capacitors have 22J printed on them. Try to get you a good close up there. See the 22J right there. So the 22 picofarad caps, they have that 22J marked on them. The 22 picofarad capacitors are C6 and C7. Just drop them in. And then go under and bend the leads outwards so that way they don't pop back out. And now we'll install the 0.1 microfarad capacitors, which we have, let's see, 6. So guys, I'm looking here at the parts list, and we have, according to the parts list, 22 picofarad and 1 microfarad. I noticed right away when I was looking at this, I said 0.1 microfarad, that don't seem right, because these capacitors are marked 105. And if they were 0.1 microfarad, they would be marked 104. So it looks like that might actually be an error in the tutorial. So we have 6 of these capacitors, and according to the parts list, C1, C2, C5, C3, C4, and C8 are all designated as 1 microfarad. So we're going to install them in the respective spots. So just like the 22s, we're going to pop these off here. You see, the version of this kit that we have at the college I work at, we have three different values of capacitors, I think. Interesting. So that's one thing to keep in mind is on this kit, when you're looking at the tutorials or the instructions, they specify 0.1 microfarad capacitors, but yet they're actually 1 microfarad. So let's go and install them into the remaining locations. So again, there's a total of 6 of these. Okay, so now we can go ahead and flip over the board, and we shouldn't have anything fall out. Keyword is shouldn't. So now we just need to go ahead and solder in these capacitors one by one. Which will bring up another topic in regards to soldering. You gotta be careful that you don't put too much solder on there. So not only you don't want to put too much solder on there because number one, it's messy, but number two, you can actually do what's called bridge over to a adjacent joint, which is not a good thing. You don't want that to happen. Okay, let's double check these. We'll go ahead and, like before, we'll go ahead and remove the excess. Another thing that's important to note is to watch for stray solder. collecting on the PCB. If you find any, be sure to remove it. Try to brush it off. That way, you don't have to worry. That way, you don't have to worry about it bridging up against a different component or different bridge or different, different trace. And these cutters must have something sticky on them because stuff keeps sticking to them. Okay, next step is to install the Shocky diode, and you want to pay attention to the direction that you install it, because diodes, they are basically electronic check valves. They only allow electricity to flow one way. You can see there's a silver marking on one side of the diode, and that indicates the direction you need to install it on the PCB. You see right there. And it's kind of like with the resistors. You bend the leads like that. And turn the leads out just a little bit so that way it holds in place. You'll go ahead and solder this in. And we'll go ahead and remove the excess leads. Now we'll install the 16 megahertz crystal. So the crystal is, it can be installed either way. The crystal, along with these caps right there, are part of the clock circuit. The crystal, you'll drop it down into place to where the crystal itself is flush with the board, or about flush with the board. And like we've been doing, we'll go ahead and bend the leads out just a little bit, which will in turn hold the device in place. You'll go ahead and add some solder. So the crystal will not need a whole lot of solder on its leads. install the LED. So the LED, in other words light emitting diode, is basically a electronic check valve that lights up. And the LED has a very small flat spot on it, which you may be able to see on camera. And the circuit board has that little flat spot printed on it, which in turn tells you which direction to install the LED. If you install it backwards, it simply won't work. Install it, set it in there where it's flush to the board, and like usual, bend the leads out to secure it into place. It would be ideal if this thing would actually stay put, but it's not going to be perfectly flat, I'm afraid. It's going to be just a little bit crooked, of course. Generally how it goes. I should mention that when you go to cut these leads, careful not to actually pull out, because you can't actually pull the trace off the board. You gotta be careful of that. Next we'll install the tactile switch, the little push button, and it's the reset switch, and it goes right here. So this particular push button is not exactly square, it's a little bit rectangular. So when you go to install it, it is pretty much like that. And it kind of pops in there, which is pretty cool, so it kind of holds itself into place when you go to soldering in, and with this there's no excess leads to take off. So here all you gotta do is just solder the leads into the board. Okay, so the switch is now installed. Push button. Now we'll install the 3.3 volt linear regulator, which is this little TO92 package right here. So, when you look at the board, the linear regulator goes right there, and you can see there's a flat spot. That's the face of the component, and you just want to make sure that you install it in that same manner. And with this, you since the leads are kind of already preformed, you just install it till it stops, till it goes no further. Now, some components like this in this package, they're not quite like that, and you have to kind of form the lead yourself. I'm just going to bend two of the leads out, that way this will kind of self-hold in place. Now, if you wanted to, you can install a lot more components through the top and then flip it over to solder everything in, but the more stuff you do at the time, the more difficult it can be. So keep that in mind. And here's something to watch out for is, see how I bent this lead out right here? Maybe you'll see, and it's kind of almost touching against that neighboring component. Now, according to this, it appears that these two leads, these two holes are actually part of the same trace, so if they do touch, I think it wouldn't be too big of a deal, but just see, just for good measure, we're going to bend that out a little bit different direction. So now we'll go ahead and solder everything in place here. There's a wee bit more to that. That one was kind of hard to see, at least from my angle of view. Okay, next we'll be installing the 5 volt regulator, which is the TO220 package, and that goes right there. So on the directions, they specify to bend the leads out into an elbow shape so that you can actually bend the component to lay face down against the PCB. Kind of like that, except I need to go a little bit further. Kind of, you can gently bend the leads over through the PCB, but gotta be careful. So we're going to pull it back out and make some adjustments. Now you gotta be careful with these leads, because if you bend them too much, you bend them back and forth too many times, they will break. So keep that in mind. Let's try it again. Because the idea is to get this package in line with the print on the PCB. You can see we're just about there. Okay, so although we aren't exactly perfect, I'd say we're about close enough. I'm going to bend the leads just a little bit to keep this in place. Now I should mention, if it does fall down a little bit, you generally can just bend it right back. Okay, so we'll go ahead and solder that in. Okay, and let's cut the excess off. Okay, so the next steps are to install the USB jack and the barrel jack connections. The USB connection, the barrel jack connection. So we're going to do the USB port first. The USB goes, get this back on here so we can see. The USB port goes right there. There's two large connections which actually are for holding the port into place, and these four right here, let's see, you also see on the board, those are the 5 volts, the ground, and the data connection. So that theoretically should just pop right into place. Yeah, it's rather interesting their choice of USB port on this design. Basically USB printer port. That was the it's a standard USB Type B port. It's not a micro. But in the computer world, you find these on printers, which is why I call them a USB printer port. Now this one will need a fair bit of solder. Make sure you install enough solder. I'm having to pull my solder out a little bit more. Because this one doesn't have quite enough on it just yet. Okay. That's better. Still not exactly perfect, just a little more. There. Hit this one again. Now we're going to do our actual connections here. Those ain't going to need much. Just a little bit. Okay. Now for the barrel jack, and I want to talk about something regarding this barrel jack. There's a little bit of a flaw in the instructions here. They just tell you to solder it in, and generally you would think to solder it in from the bottom, which is true. You definitely want to solder on the bottom, but not only that, we'll get to that in a moment. So first we're going to solder in the bottom. Now this one's going to be a little bit trickier because you're going to have some means of holding this in. And what I'm going to do is I'm going to actually take the PCB out of the vise. Get all our trimmings out of the way here because we don't want to create any short circuits. I'm going to set this on the table, directly on the table, resting against that power jack. And now we can solder it in. And since this is a pretty large connection, we're going to need a pretty fair bit of solder there. You have to be pretty quick with this because you don't want to melt the plastic in that connector. We'll have to pull out some more solder. Okay, so I want to take a quick look here at these sockets. Yeah, that's probably these and the headers will be the most tedious part of the whole project here. It looks like we did pretty good on those. So now we got to install the various headers. So the Arduino style headers go right here. And getting those to stay in place will be a bit more difficult. So what I'll probably have to do is do what I call preload the soldering iron with some solder, and then set the header into place. So let's go ahead and open the vise up a bit more because we're going to hold the PCB in place through the USB port. So what we gotta do is just line up the various, match up the various headers. And it looks better when they're straight. Let me tell you, they look better when they're straight. So we gotta preload some solder onto the soldering iron. So that way we can set this into place. And once you solder in one of these headers, it will kind of hold the rest of the thing in place for you. And we'll have to come back and re-hit that particular joint because that's not a very good solder job right there, but it's holding this in place. Go back and revisit that one. Near much better. Anytime you're working with really close stuff like this, there's a chance that you can bridge over. And if it happens, you have to use a solder sucker to remove the excess solder or desoldering wicker braid. And that one is kind of in crooked. Like I say, it can be difficult to get these things to go in exactly straight. So I'll show you what I mean here. See how it's kind of crooked? Yeah, I was hoping it would have went in a little straighter than that, but it is what it is. So I guess since that one's kind of leaning out just a little bit, we'll install this one the same way. And I mean, to be honest, it's not really going to hurt the fact that it's not really going to hurt that it's leaning out a little bit. I mean, considering that your wires are going to be probably coming from, like, let's say, a breadboard nearby or something like that. So, in a way, it's not such a bad thing. Just kind of prefer them to be straight. So I'll install the second header over here, kind of in the same direction. Have it leaning out slightly. Okay, just I'm going to look over these connections, and everything there looks alright. And of course the board is the header is towed outward just a little bit. So I'm not going to lose any sleep over it, to be honest. So again, we're not clamping down hard with this vise. I mean, it's just, as you can see, it's not very tight on there. So I guess since the headers on this side are leaning kind of that way, I'll have these kind of pointing out that way. Now for our last header. And we still have this right here to install, which is in the next step. And I should mention in the in their directions they mention that if you have an Arduino shield, use the shield to help align the headers when soldering. Yeah, it's hard to get those things perfect, I'll say that. Okay, so now we need to install the header. So the header in particular, this is going to be the I think the ICSP header. Which is going to be right there. So this is our header. It's just 6 pins. What we got to do is snap it in half. Like that. And there's 2 separate ones. And this one might be a bit more tricky. I'm going to get it flat against the PCB. Now I do have an idea for this. Let me grab something real quick here. Okay, so what I'm going to do here is got a couple of motherboard jumpers. And we'll take these 2 headers. Amazingly, this one has managed to find its way under a capacitor. There. Insert this way. Just like that. Insert the second one. And then insert the second jumper over top of this. This will help ensure that this header goes into the board perfectly aligned. It'll also give me a little something to kind of brace my finger on because I don't want to burn my finger. So we're going to place this back into the device. So I've got to preload some solder onto the iron. I know those ain't perfect joints, but I have to go back and touch them up. The idea is just to have something there to hold things in place. Yeah, this header is super small, so okay. Just double check everything. I think down there I might need a little more solder. There. So now we can go and remove our jumpers. So now this header is installed, and you can see it's in there straight. So what we gotta do next is clean the flux residue off of this board. You can see there's a whole lot of flux on there. And what we'll do is I'll go get some rubbing alcohol and some Q-tips, and we'll get that cleaned up. Okay, so now's a good time to go and review your board. Make sure you don't have any bridged connections where two different joints are bridged over. And it looks like we're good there. I'm going to actually cut off a little bit more excess on some of these connections here. I see we got kind of a mess there on a couple of them. So we're going to take care of that. This is it. Some of these are hard to get to with these particular cutters. Okay, so now what we'll do is take some Q-tips and rubbing alcohol and just kind of swab this thing over real good. Yeah, because the solder itself has flux in it, and it's kind of a mess. The flux is it helps us. It's kind of like a cleaner. It helps the solder better adhere to the conductors on the circuit board. And of course, make sure you have extra cotton swabs or Q-tips, because as you can see, when you rub across some of these connections, they just shred apart. So you generally will need a few. Just gonna flip that over. Yeah, it's good to have a few on standby just in case. You may be able to get by with just these. Just this one, I don't know. Still not the best. It's not the most perfect cleanup, but hey. Let's grab a fresh Q-tip. Just do it again. And of course, that rubbing alcohol, it will evaporate. Yeah, rubbing alcohol is actually it's a pretty popular cleaning solution for electronic components. Okay, so while that's drying, we'll go ahead and reinsert we'll insert the microcontroller, or the ATmega328P, and the USB to UART chip. I'm also going to clean up around this power jack because I did solder on top of the board right there. Anyways, so we'll grab our two ICs. Start with the USB to UART, and you can see there's a little dip there. And that little bubble right there, that indicates pin number 1. So just make sure you install it in the same direction. And when you install these, be careful that you don't bend pins. Now you may have to bend all the pins inward a little bit to get it to fit, but do not force. Okay, that one is in there. Now we're going to do the ATmega328P. I should mention that the microcontrollers in these particular kits, are already flashed with the necessary bootloader for Arduino. Because you can buy these controllers off the internet from an electronics supplier like the rest of these components, but you actually have to flash the Arduino bootloader onto this, and there is actually a process on how to do that. You can actually use an Arduino to do that. I'm not too familiar with that process just yet. Though in the future it might be a video, so who knows, we'll see. I may actually be shooting it from my place of work, I don't know. since part of what we do in my area is prepare these kinds of kits for a couple of our classes. So, just like before, we had to bend the pins in just a little bit. Make sure they're pretty well lined up though. And of course, make sure that the little dimple in the side is facing the right direction. Yeah, these dip sockets can be a little challenging. Just take your time with them. And once you feel it starting to line up, just look over it again. Make sure every pin is lining up. And you just press it into place. Had to kind of walk it in there, but so now the ICs are installed. Okay, everybody. So there's your close look at everything. So now we're going to plug this in to a USB cable. And you can hear that it was detected by the computer. And I'll just go in, go to the control panel, and go into the device manager and see if we can see the USB to UART. I'm not sure, but anyways, we're going to go ahead and test this. So it tells you to press the reset button and you should see the LED blink. And you can see the LED blinks, so that indicates that this board is functional. So now, unplug this. So we have soldered up a through-hole Arduino. You can now use this to do whatever you want with it that an Arduino can pretty much do. You could load programs onto it. You basically have your own Arduino Uno that you built yourself out of through-hole components. Pretty cool, huh? So anyways, I hope y'all enjoyed this video. Thanks for watching. Well, everybody, that's it for this video, but don't forget there's a lot more interesting stuff on the channel to check out. Also, if this is your first time visiting this channel, feel free to subscribe to keep your channel, and also don't forget to tick the bell so that way you'll get notified of new video posts. If you like this video, please give it a thumbs up, but if you really didn't like it, there is the alternative option available as well. Also, feel free to check out my second channel, CubeCompMTDX. There you'll find videos about bicycling, weather,
elevator tours, and all sorts of other neat, interesting stuff. I hope you guys enjoyed this video. Feel free to come back, and thank you for your support.